Good morning, students. In the previous class, we have discussed about the various properties of the inverse Laplace transformations. The change of scale property, the first shifting property, and many more. So today first we discuss about the second shifting property for the inverse Laplace transformation. Second shifting property for inverse Laplace transformation. The statement of the property says that the second shifting property, this statement says that if the Laplace transformation of a function fx with respect to p is equals to fp, or in other words, we can say if the inverse Laplace transformation of fp is equals to fx and a function gx is defined such that the value of it is 0 when x is less than a, and f of x minus a if x is greater than a. If a function gx is defined such that its value is 0 when x is less than a, and its value is f of x minus a when x is greater than a, then the inverse Laplace transformation of e raised to minus ap f of p, the inverse Laplace transformation of e raised to minus ap f of p with respect to x, this is equals to f of x, or rather this is g of x, not f of x, this is g of x. So we will prove this property by the definition of the Laplace transformation, as we know that the Laplace transformation of gx with respect to p, the Laplace transformation of the function gx with respect to p is equals to integral 0 to infinite e raised to minus px gx dx. As the function gx is defined in different intervals, so we will break this interval in the given intervals. So we write integral 0 to a e raised to minus px gx dx plus integral a to infinite e raised to minus px gx dx. But the function gx is defined as 0 in the interval 0 to a, and it is equals to f of x minus a if x is greater than a. So we write it as 0 plus integral a to infinite e raised to minus px f of x minus a dx. So if we solve this one, we get the Laplace transformation of gx with respect to p is equals to integral a to infinite e raised to minus px f of x minus a dx. To calculate the integral in the right hand side, if we put x minus a is equals to t, then dx is equals to dt. So putting these values in the integral in the right hand side, we get the Laplace transformation of gx with respect to p is equals to integral 0 to infinite e raised to minus p into x, that is a plus t ft dt, or we can write it as integral 0 to infinite e raised to minus ap integral e raised to minus ap e raised to minus pt ft dt. Or we can solve this one as e raised to minus ap integral 0 to infinite e raised to minus px fx dx. The integral in the right hand side is nothing but the Laplace transformation of the function fx, and the Laplace transformation of the function is given as fp. So this is equals to e raised to minus ap into f. Now taking inverse Laplace transformation, on both the sides, we get the inverse Laplace transformation of the left hand side, Laplace transformation of gx with respect to, if it is inverted, then it is equals to gx. So gx is equals to the inverse Laplace transformation of e raised to minus ap f of t with respect to x. This is known as the second shifting property. Now we have discussed about the change of scale property, first shifting property, second shifting property. Then we can apply these properties to solve the inverse Laplace transformations of the various given functions. So first of all, if you calculate the inverse Laplace transformation of a function which is given as 4p plus 12 upon 4p plus 12 upon p square plus 8p plus 16, p square plus 8p plus 16 with respect to x. So we have to calculate the inverse Laplace transformation of a function fp, which is given by 4p plus 12 upon p square plus 8p plus 16. Now we can write this one as inverse Laplace transformation of 4p plus 12 upon p plus 4 whole square with respect to x. We can write this one as p 4p plus 12 upon p plus 4 whole square, or we can write it as inverse Laplace transformation of 4p can be 4p plus 12 can be written as 4p plus 16 minus 4 upon p plus 4 whole square with respect to x. We will manipulate this one to use the various properties of the inverse Laplace transformation, and this can be written as inverse Laplace transformation of 4 into p plus 4 minus 4 upon p plus 4 whole square with respect to x. Or we can write it as 4 times, if we use the linearity property for the inverse Laplace transformation, we can write this one as 4 times inverse Laplace transformation of 1 upon p plus 4 with respect to x, minus the second one is 4 times the inverse Laplace transformation of 1 upon p plus 4 whole square with respect to x. Or we can write this one as the Laplace transformation 4 times the inverse Laplace transformation of 1 upon p plus 4 with respect to x, minus 4 times e raised to minus 4x, the inverse Laplace transformation of 1 upon p square with respect to x. Here we have used the first shifting property as 1 upon p plus 4 whole square is equals to e raised to minus 4x inverse Laplace transformation of 1 upon p square. The first shifting property says that the inverse Laplace transformation of f of p minus a with respect to x, this is equals to e raised to ax f of that is inverse Laplace transformation of fp with respect to x. So using the first shifting property, we get this result as this one. And finally, if we write the inverse Laplace transformation of 1 upon p plus 4, 1 upon p plus 4 is the inverse Laplace transformation of e raised to minus 4x. So this is 4 into e raised to minus 4x minus 4 e raised to minus 4x into the inverse Laplace transformation of 1 upon p square is nothing but x. So solving this one, we get 4 e raised to minus 4x into 1 minus x, which is the required inverse Laplace transformation of the given problem. If we solve the another problem, find the inverse Laplace transformation of 1 upon under root p square minus 4p plus 20. 1 upon under root of p square minus 4p p square minus 4p plus 20 with respect to x. The inverse Laplace transformation of 1 upon under root p square minus 4p plus 20. If we manipulate this one, first the inverse Laplace transformation of 1 upon under root of p square minus 4p plus 20 with respect to x. This is the solution of the problem. If you manipulate this one as, then this can be written as inverse Laplace transformation of 1 upon under root of p square minus 4p plus 4 plus 16 with respect to x. Or we can write this one as the inverse Laplace transformation of 1 upon under root of p minus 2 whole square plus 4 square with respect to x. 1 upon under root p minus 2 whole square plus 4 square, that is 16. Now first we use the first shifting property. So by using the first shifting property, this can be written as e raised to 2x inverse Laplace transformation of 1 upon under root of p square plus 4 square with respect to x. The first shifting property, as we have discussed earlier, the inverse Laplace transformation of f of p minus a with respect to x is equals to e raised to ax inverse Laplace transformation of fp. So here using the first shifting property, we get this result as e raised to 2x inverse Laplace transformation of 1 upon p square plus 4 square with respect to x. And finally, if we get the inverse Laplace transformation of 1 upon p square plus 4 square, that is the inverse Laplace transformation of under root 1 upon under root p square plus a square is j0ax. So here a is 4. So we get the inverse Laplace transformation of 1 upon under root p square plus 4 square, that is j0 4x. So the inverse Laplace transformation of 1 upon under root p square minus 4p plus 20 is equals to e raised to 2x j0 4x. Thank you very much.